Rightio, so the first question's asking us to determine the stationary point. How do we go about that? First step is to derive it. So we get f dash x equals 4x minus 12. Unless my deriving is wrong. Then what do I do? Sub in 0. Do we want to clarify what that means? Why do we let f dash x equal 0? We want the gradient to be 0. Why do we want the gradient to be 0? Page.
I don't know.
What do you think? What's a gradient of 0 look like?
Of 0.
Yeah. Use your arm to show me a gradient of 0. Yeah, what's your question?
Oh, I don't know, so.
Alright, everyone else put your arm up, show me a gradient of 0, everyone. Some weird looking 0 gradients here, they should look something like this.
Yeah.
Okay, so why would that be the gradient of our turning point or our stationary point?
'Cause that's when
Draw a stationary point.
It's just when it's
So, is this a
flat
stationary point?
at the top.
That's a stationary point there.
Yes,
Is this a stationary point?
at the bottom.
Okay, is this a stationary point?
In the middle.
Okay, good. Now tell me about the gradient at this point.
It's flat.
And this point?
Yes, it's flat.
Oh, okay, good. So can you show me what a gradient of 0 looks like, please?
It's flat.
Okay, good. So we let that equal 0. 0 equals 4x minus 12. We solve and we get x equals 3. I'm assuming we can solve in our head. Sweet. I'm not going to do the second one because I'll leave that up to you. I'll leave some surprises. But for our tables here, we can use these tables to determine whether it's a max or a min. Now the way we do that is we have our stationary point in the middle or between two other points. In this case it's 3. What will the gradient be at that point in time? 0. Pick a value less than 3. Geez, they're good. Pick a value greater than 3. 4. Great idea. Thanks, Sam. Good idea. What we then do is simply sub f dash 2. So that would be 4 by 2 minus 12, which equals negative 4. I don't care, I'm going to write negative 4 just for now, but I don't actually care how big it is. What I do care is that it's negative. I then sub f dash 4 in. What does f dash 4 equal? 4 by 4 minus 12, which is 4. Again, I don't care about the size of the number. I just care that it's positive. So a lot of the time when I'm doing this for myself, I'll just write minus VE and plus VE. You'll never guess what that means. Very good. What I want you to do now is draw the lines, some lines that would represent that. So as an example, just over here, find some new bit of board. If I was to draw that, what would I expect the middle line to look like? I've already done the middle line. It is flat. So it's x equals 3, 2 and 4. In the middle it's flat, correct? What's a negative gradient look like? Starts high, goes low, correct? What would we expect the positive gradient to look like? Starts low, goes high. What does that tell you about this point here? It's a min or a max? We have ourselves a minimum. Want a better colour now. So above this point I would write ta-da. Sweet. So that's how we use our tables. I'm going to show us a technique that doesn't require tables shortly, but not yet. So I want you to do question 2 and then I'll show you the shortcut Because shortcuts are for those who know the way. And we empirically do not know the